right, this is Honors Algebra 2 Pre-Calc. We are doing an extra video on the topics we saw in 3.1 and 3.2, but we're specifically focusing on solving systems of equation word problems. So I know that that's a thing that causes great anxiety. I know that when you open your math book or you open a test and you turn and see a paragraph of writing, we all have a bit of a panic attack, and part of my job is to try and teach you how to get through that and calm down. So first thing you want to do is read through the problem to determine your unknown quantities and assign variables for your unknowns. Then you want to read through again and use the sentences to write equations with the variables you've established. You generally need as many unique equations as you have variables. So for instance, if you have an x and a y, you're going to need 2 equations. If you have an x, y, and a z, you'll need 3. So you can have fewer equations than you have variables, but what that means is if you do that, you will not get a unique solution. You'll get one of those consistent dependent, essentially. Like you're going to get a formula where it's not really consistent dependent, it's so much as it's a situation where you're going to have infinite solutions of a specific form. But it doesn't necessarily mean that the two lines are the same. Excuse me. So we're going to solve our system using graphing, substitution, or elimination. You're also going to learn matrices in Chapter 4 as an option. And then you're going to answer the question in words with correct units if applicable. So in this video, we're just going to do a bunch of practice problems. So all right, example 1. Find the value of 2 numbers if their sum is 12 and their difference is 4. So in this situation, my unknowns are 2 numbers, okay? So I'm going to call x the first number, and I'm going to call y the second number, okay? And what I know is if I add x and y, right, their sum is 12, so that's my first equation, right? The sum, their sum is 12, right? That's my first equation, which we can do in blue if we want to match what that sentence says. So the first equation, right? And their difference, if I subtract them, is 4. So if I subtract them, x minus y is 4. Well, there's my system, right? I assigned my variables. I've created a system. I have 2 variables and 2 equations, so that's what I need. So then I just need to figure out how to solve. Now in this situation, this is already, so this is made for elimination, right? It's already lined up. I've already got the y's set to eliminate, right? This is just begging me to use elimination. You don't have to, but man, it's a good call. So when I add straight down, I'm going to get 2x. The y's are going to cancel, and I'm going to get a 16. So I'm going to get that x is 8, right? When I plug in x is 8, so I'm going to plug into the first one. 8 plus y is 12. Seems to me that y is 4. And you can verify that if you do 8 plus 4, you get 12, and 8 minus 4, you get 4. So, so then the last thing I want to do is make sure that I answer the question in words and units if applicable. Here there are no units. We're not talking feet or centimeters, right? So in this case, the numbers are, that's not how you spell R, are 8 and 4. And that's all I need to do, okay? All right, so moving on to our next slide. P1, you're going to find 2 numbers, same situation. Okay, so again, assign variables. Pause me if you want. Okay, so the difference of 2 numbers is 13. Their sum, is 3. Their sum is 13. Find the numbers. So again, I'm looking for 2 numbers. So I'm going to go ahead and call x one number, and I'm going to call y the other number. So I know that their difference is 3, so we'll say x minus y is 3, right? And that their sum is 13, so x plus y is 13. I'm going to argue this is another one where it's tailor-made for elimination because those y's are naturally going to eliminate, and I'm going to get 2x equals 16. X is an 8. Once I know x is 8, I'm going to pick the one with addition because I think it's easier. 8 plus y equals 13. I get y is 5. So when I answer my question, the numbers are 8 and 5. Okay? All right, moving on to the next one. Flying to Kampala with a tailwind, a plane averaged 158 kilometers per hour. On the return trip, the plane only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind and the speed of the plane in still air. Okay, so here's the idea. And so if you're not familiar with the idea of a tailwind, so basically what's happening is you have this airplane, okay, and it's flying. Okay, so it's flying. A tailwind means that the wind is pushing the plane to move it faster, right? That there's some wind speed and there's some plane speed. Okay, so I'm going to use, I'm going to call the speed of the wind W, and I'm going to call the speed of the plane by itself P, like the speed it's actually flying. And that's me assigning my variables. If you want to write it somewhere else, you can. So this is called a tailwind, okay? The tailwind means that the speed of the plane and the speed of the wind are pushing in the same direction, meaning the wind speed plus the plane speed is apparently 158 kilometers per hour. But when you fly back, the wind is still the same speed, but when you fly back, oh, that's a terrible airplane, but the other one was much better, it's fine. Okay, but now the plane's flying this way. Well, now the plane's got to work against the wind, right? Now the plane's obviously winning. The wind is not pushing the plane backwards, right? So the plane minus the wind, because the plane is clearly the bigger number, right? The plane is moving forward, is going to be 112. That's not how you write a 1. Okay, cool. So now what I've done is I've assigned my variables, right? So I said wind speed. So the speed of the wind was W. The speed of the actual plane, like the speed the plane is intentionally trying to fly, not counting the actual airspeed that the whole thing is moving, is P, right? And I have two equations, right? I have one that says when they were working together, which is what a tailwind means, right? I have this, right? And I have one that says when they were working against each other, right? Flying back into the wind would be this, right? That's my second equation. So the one thing I would change here is that I put the W at the back here and I put the W at the front here. So I would change my red equation to be P plus W equals 158. And I'm going to point out that yet again, this problem is tailor-made for elimination because the W's are already set to eliminate, right? So what's going to happen is I'm going to end up with a 2P equals, it's a 60 and a 70, so 270. I'm pretty sure. And then when I divide, I'm going to end up getting that the plane is traveling at 135 kilometers per hour, right? And then I know that I could easily find the wind by saying that the plane plus the wind is a 158. So the wind is 158 minus the 135, right? Which should be 23 kilometers per hour, right? And then you can verify that if you do the 35 minus the 23, you'd also get the 112, which you do. So when I go to answer in words, and I didn't really give myself the space to do it, but if I answer in words, I would probably say something like the plane moves 135 kilometers per hour, and the wind is 23 kilometers per hour, right? And oh, my bad, every time, sorry. Anyway, so make sure that you have units if there are units, right? So those are my values and there are my units. Let's go ahead and do another problem. So go ahead and try a boat going downstream. You are welcome to pause me if you want. So a boat traveled 336 miles downstream and back. So that's the total amount that it traveled in each direction, 336 down, 336 back. The trip downstream took 12 hours. The trip back took 14 hours. What is the speed of the boat in the water? What is the speed of the current? Okay, so let's kind of get a picture of this. All of my boats are sailboats. I know that that's not how boats work, so don't judge me too hard. Okay, so we're going to assume that the river's going this way. River going this way. Okay, so this is downriver. Okay, so basically, the issue here is that going downriver, we're traveling at, essentially we have the current plus the boat, right? So essentially, the speed going downriver, right? The speed downriver is actually the speed of the boat plus the speed of the current, right? But the speed going upriver is the speed of the boat fighting against the speed of the current, right? So here, B is the boat speed in still water, right? It's this boat speed in still water, and C is the current speed, right? It's how fast the water itself is moving. So basically what we know is that the speed downriver, right, was 336 divided by 12, right? And the speed upriver, right, fighting your way back, was 336 divided by 14, right? Because this was miles per hour, right? And this is miles per hour, right? That's how far. So that's how far this boat traveled. So essentially, this is the same problem as the airplane problem. It's just that you're not loving the fact that there's this 12 and the 14 on the bottom. There's a couple different ways to deal with that, right? One way to deal with it is just to quickly check and see if 336 is divisible by either of those numbers, right? So you could do 336 divided by 14 and see what happens. And hey, it is. And 336 divided by 12. And hey, it is. So turns out that this gives me two equations. B plus C is 28. B minus C is 24. And now suddenly it's not so bad, right? So it was kind of ugly when you had it in this fraction form, but it's not so bad when you check it out. So 2b equals, when I add these together, I should get a 52, right? And so b is 26 miles per hour, right? And then I can pick either of these equations. I think the easiest one is b plus c, b plus c. So 26 plus the current is 28. So the current must be 2 miles per hour. And then I would go ahead and answer in words, right? So I would say something like the boat current can't talk. The boat speed is 26 miles per hour, and the current speed is 2 miles per hour. And again, I would probably not put this in the same spot, but I'm kind of low on space. So I'd probably be like, oh, hey, that's my answer. Boom. Okay? All right, let's keep going. The school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior tickets and 2 children's tickets. Find the price of a senior ticket and a child ticket. So when you're looking for your unknowns, it's often given to you, not always, but often, in this last line, right? This is telling me what my unknowns are. So I'm going to go ahead and you could use like S for senior and C for a child, or you could just stick with the X and Y's, it's fine. So I'm going to do X is the cost of a senior ticket, and I'm going to call Y the cost of a child ticket. So now I need to go back and see if there are sentences that give me equations. Well, I know that day 1, there were 3 senior tickets and 1 kid ticket for $38. So on day 1, I know that 3x plus y is going to give me a 38. And on day 2, $52 was made by selling 3 senior tickets and 2 children's tickets. So on day 2, 3x plus 2y was $52, right? So I'm going to argue that this is another good system for elimination. If you chose to pick substitution, I would suggest that you solve for this y because it's already all by itself. But I'm going to go ahead and multiply the entire denominator by, the entire bottom equation by a -1. And so I'm going to get 3x plus y equals 38. And I'm going to have my second equation to be a -3x minus 2y equals -52. When I add straight down, the x's will cancel. I'll get a -y equals a -14. So y must be 14. Well, remember that that's the cost of a ticket, right? So this tells me that a child ticket is $14, right? And then when I go to find the other value, right, when I go to find my x, I'm just going to go ahead and use the second one. So 3x plus 14 equals 38, right? 3x should be a 24, so x is $8. So a senior ticket is $8. Cool, and those are my answers. All right, so let's keep moving forward. For P3, Matt and Ming are selling fruit for a school fundraiser. Customers can buy small boxes of oranges or large boxes of oranges. So right now, hey, there's a small box and there's a large box, and those are probably my unknowns. Matt sold 3 small boxes of oranges and 14 large boxes for a total of $203. Ming sold 11 small and 11 large for $220. Find the cost of a small box and a large box. So again, I'm going to go ahead, I'm going to make the cost of 1 small box be X, and I'm going to make the cost of 1 large box be Y. You could use S and L if you want, okay? So it's okay to assign your variables by just writing on the actual problem. As long as it's clear what your variables are, I'm not worried about it. But make sure that you're clear that they're the cost of both of those things. So for Matt, right, here's what we know about Matt, right? We know that Matt, we'll go ahead and put his thing in red. Matt sold 3 small and 14 large for $203. So that's a 3x plus 14y equals 203, right? And then for Ming, right, for Ming, we know he sold 11 of each and made $220. So 11x plus 11y equals 220. Okay, so the one thing I'll point out here is that as this is written right now, it's not super fun to do elimination because you're going to need the least common multiple of an 11 and a 3 and 11 and a 14. However, I would point out that this entire equation is divisible by 11. So it might be worth your time to divide the entire equation by 11 to get x plus y equals 20, right? So you don't have to, but it's helpful, right? And then now knowing that, I could either use substitution or I could go one step farther and say, hey, you know what, I'll times that by a -3. By doing that, I then end up with -3x minus 3y equals -60, which lines up really well with my 3x plus 14y equals 203, right? And so then I could use elimination on this. Again, I default to elimination, not everybody does, but that's sort of my preference. So when I do that, I end up with an 11y, right, equals a 153. That doesn't seem right. Oh, sorry, it's 143. That makes way more sense. Sorry, sometimes adding is hard in my brain. Okay, cool. So now that's right because that means y is 13. I was hoping we'd get a reasonable, nice number. So y is 13. So it costs $13 for, y was the large box. So for a large box. So again, and you can have your answer be included right down here. You don't have to write it as a full sentence, but you need to make sure that you say it's dollars. You need to make sure you indicate it's for a large box. Once I know what y costs, I'm probably going to use this easy version where I had that x plus y was 20. Well, that means x plus 13 is 20. So my x is 7, which means that it's $7 for a small box. Cool. All right. So last ones, we're going to do an E4 and a P4, and then that'll be it for this video. So the State Fair has a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 8 vans and 8 buses with 240 students. High School B rented and filled 4 vans and 1 bus with 54 students. Every van has the same number of students in it as did the buses, meaning a van has a designated number of kids and a bus has a designated number of kids. So I'm going to go ahead and use, I'm going to use X for the number of kids in a van, and I'm going to use Y for the number of kids in a bus. And again, we're assuming that they're all the same size bus, right? So a bus fits however many kids, and that's it. Okay, so I'm going to have one equation for High School A. Well, High School A had 8 vans, so 8x plus 8 buses, 8y equals 240, right? And High School B had 4 vans and 1 bus, and it was 54, right? So again, substitution or elimination works here. I would like to point out that this is a really good time to notice that the entire top equation is divisible by 8. So your numbers get a lot smaller if you say, hey, you know what? I'm going to divide this by not just an 8, but a -8, because that would make it easy elimination. So I'm going to get -x minus y equals -30. And now that lines up really well with my B that was 4x plus y equals 54. And again, you don't have to see that, but it's handy if you do. So when I add straight down, I get 3x equals 24, so x is 8, meaning that there are 8 people on a van. So in my answer, I'm going to say, oh, 8 people per van, right? I know that there are 8 people per van. And then since I know 4x plus y equals 54, sorry, 54 every time with this pen. So that's going to be 32 plus y equals 54, right? And when I subtract the 32 over, I get that y is 22. So there are 22 people per bus. Okay, and that's my answer. You'll notice that I'm not asking you to classify any of these. In most cases, they are going to be consistent, independent, because it's a word problem. It's going to have an answer, right? Okay, so cool. Here we go, P4, and then that'll be it for these. Senior class at high school A and B plan separate trips to New York. This is the same basic problem, right? So I'm going to go ahead and call X the number of people on a van. I'm going to call Y the number of people on a bus. And again, you don't have to use those. You could use or V and B for all I care. It doesn't matter. Okay. Don't use P for people because they're both people. Okay, so school A has one van, so that'd be X, plus 6 buses, which would be 6Y equals 372. And school B has 4 vans, so 4X plus 12Y equals 780. Cool. And this is a 2, but it looked like a 3 the way I wrote it. Okay, so couple things to notice. I would notice that it may or may not be worth your time to divide the entire second equation if you want by 4, right? It might be worth your time. It's up to you. I would argue it probably is, because if you divide the entire thing by 4, right, or more specifically, if you divide this whole thing by a -4, right, like -1/4, you're going to end up with a negative X minus a 3Y. Let's see, that'd be 780 divided by 2 is 390, divided by 2 again would be a 150 and a 45, so 195. I think it ends up being a -195, but I'm not sure. We'll double check, because, sometimes my brain is tragic. So let's do 780 divided by 4. Hey, 195. Awesome sauce. All right, so, and then this guy, right, was already an X plus 6Y equals 372. When you add straight down, the X's will cancel. You'll get 3Y equals, it's 5 shy of a 200, so it's a 177. No, yes, 177. Okay, and when you divide 177 by 3, it'd be a 9 for the 27, and it would be a 50, so 59 maybe. Boom. Awesome. All right, so I get that Y is 59 people, so 59 people per bus, right? And now that we know that that's how many people are on a bus, we go ahead and find X. Well, I know that X plus 6Y, so 6 times the 59, is a 372, right? So I'm going to get that X is 372 minus, this would be a 360 minus 6, so it's a 354. So X should be 18 people on a van, right? Because if I subtracted 8, and yep, there we go. All right, so there's your P4. It's not wrong to put these in your calculator to find the actual numbers if you're like, hey, I just don't feel like doing that. All right, cool. So that is the end of this video.